we know that the work done by the net force is the product of the net force and a displacement. And if we don't have a constant net force, we can integrate. And if the net force and the displacement aren't in the same direction, we want to express this as a dot product of the vector F net with the vector delta x, or the integral. Okay, and that would be a line integral. We're not, we'll talk about what that is, but we're not requiring anybody to do a line integral in this course, as that's a topic in a course for which, well, in a course it's not prerequisite for this course. So we go back to the simplest idea, that it's just net force times displacement. And that's the work done by the net force, and that's equal to the change in kinetic energy of our system, whatever that system might happen to be. Okay, so, well, the net force acting on the system, and I've got the on there to be extra careful, or to encourage you to be extra careful, that you're always talking about, when you do this, you're always talking by work done on the system. So you're always talking about the force exerted on the system. In many cases, the system exerts a force that's more obvious to you than the force that's being exerted on the system, and you'll want to use that force in this equation without being careful. Okay, so I could put the subscript on for every force, because now we're going to assume that we have forces, a number of forces acting on the system. Okay, and we just call those forces F1 through Fn. And I'm going to just go ahead and put the on subscript on everything here, because again, I think it's really important to always be sure that you're talking about the forces acting on the system, and then understanding the force acting on the system gives you the work done on the system. Okay, that's what all these ons are doing. Okay, well anyhow, so the sum of the forces on the system is what you get when you add up all the forces on the system, and that's multiplied by delta x, and then because of the distributive law, it's obvious that we just get force 1 times delta x, force 2 times delta x, etc. And that gives us the work done by force 1 on the system, the work done by force 2 on the system, the work done by force sub n on the system. And that's equal then, that sum is equal to the change in kinetic energy of the system, and you don't need on there. Kinetic energy doesn't act on or by. Okay, and I use delta, and that's not standard. I like to use a delta with my work to indicate the work done on some interval. And usually we're going to think of that as some displacement interval, or over some path. Okay, it has a starting point and a stopping point. So we have the work done between the starting and the stopping point. And I use a delta for that. Again, it's not standard notation, it's not ideal, but neither is it ideal, in my opinion, to not use a delta on it. So there's no perfect notation. This tells us that we can separate the work done by the net force into the work done individually by each of the component forces, which are then added up to get the total work.